everyone, welcome to a new video. In this video, I'm going to discuss another Leetcode problem, and that problem is based on arrays. Okay, so now let's see the question. So the question is merge intervals. Given an array of intervals where intervals of I is equals to start of I and end of I, merge all the overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. Okay, so basically you will have one subarray. In the subarray you will have one starting number and another number you have that will be your ending number. Okay, so let's see some examples to understand it better. So in the first example, these intervals arrays are given to you. Okay, so in this intervals array you have multiple subarray. In each subarray size is only 2 because each subarray is representing the starting and the end numbers. Okay, so like in the first subarray you have this, the starting number is 1 and the ending number is 3. Okay, with the second subarray your starting number is 2 and the ending number is 6. So now you have to find out the overlapping of the subarrays. So if you see the first example and if you check the first two subarrays, then you can see they have some overlapping. Why so? Because in the first subarray, what are the intervals you have? The intervals you have from 1 to 3, right? So now if you check the second subarray, then you can see it is starting from 2 and it is ending at 6, right? So it means that this 2 is lies between 1 to 3, right? So it means that they are having some overlapping. It means that you can just definitely merge these two subarrays. So I am just merging these two subarrays. Okay, and now your final subarray will be 1 to 6 because 1 to 6 subarray you will have this 3 also and also this 2. Okay, that's why you can easily merge it. Okay, so this 1, 6 subarray you can see in your output also, right? So I think it's clear. So now in the third subarray you can see it is starting from 8 and it is ending at 10. So if you check the last subarray, it is ending at 6. It means that there is no overlapping, right? Same goes to last subarray also. It is starting at 15 but the last subarray it is ending at 10. So it again there is no overlapping. So you can keep these two as it is. Okay, so I am just keeping this same. So now you can see the same explanation here also, like since interval 1, 3 and 2, 6 overlap, merge them into 1 to 6. Okay, so now let's see the second example. In the second example, these two subarrays you have. Okay, so 1, 4 and 4, 5. Definitely your output will be 1, 5. Why so? Because there is a overlapping. Because this 4 is overlapping. Okay, so you can just merge it to 1 to 5. I think overlapping concept is little clear to you. So now let's see another example to understand it better. Let's see this example. In this example you have these subarrays. Okay, you have 4 to 5. There is no overlapping because it is starting at 2 and ending at 3 and it is starting at 4 and ending at 5. No overlapping. Same goes for 6 to 7, 8 to 9 also. But with the last subarray you can see it is starting from 1 and it is ending at 10. So in this particular interval, if you can just calculate it, then you can understand that in this particular interval you can get all these numbers from 2 to 9. All these numbers are lies between this 1 to 10. So in your output also you can mention the same. Okay, so output will be 1, 10. Okay, and it will be 2 dimensional. So you have to keep this way only. So this will be your final output because this 1 to 10 interval you will have all these numbers. Okay, so you can just remove this subarray and you can just keep only this subarray only, because in this subarray you will get all these subarrays numbers you will get in this particular subarray. So to solve this problem I will use stack. Why? Because using stack you can easily solve this problem. And how stack will be beneficial to solve this question. You can understand that when you will see the solution. Okay, so now let's see how we can solve this problem using stack. Okay, so first I will use one stack, or I will take one stack, and the stack data type will be integer type array. Okay, here I am just taking one stack of integer type array. Okay, so now next what I need to do, just traverse this intervals array. Okay, so for int I, here I am taking integer type array of stack, because in this stack, in each entry I will store one sub array, and this sub array will contain two numbers. First number will represent the starting, and the second number will represent the ending. So suppose this stack I have, okay, and each stack entry I am storing integer type arrays. Okay, so each array is representing two values. Okay, means this arrays is contains only two values. First value is the starting, okay, and the second value is the ending. Okay, these two values is storing each particular array. Okay, and this particular array I am storing in our stack. I think it's clear. I think this mapping thing is clear. So you have one stack, and each stack is storing integer type arrays, and this integer type arrays are storing two values only. First value is the starting position, and the second value is the ending position. I think this through this picture you can easily imagine it. Okay, so now next what you need to do, I am just traversing our intervals array. Okay, and it is a two-dimensional array, and each sub array you have only two values. Okay, so that's don't use any extra for loop, because I can easily access a particular sub arrays by the index position only, because I know that in each sub array we have only two elements, and the two elements I can access by 0th index position number and the first index position number. Okay, so now first what I will check, if our stack size, okay, if our stack size is totally empty, then there is no need to think about it. We just add that particular sub array in a particular stack. Okay, so now sk.push, what I have said in our paint, if you see, in the first time I will store the starting, and the second index position I will store the ending, right? So now next what I will store intervals. So this will be the first time when our stack size is totally empty. Okay, it's okay. So for the first time we will just simply add our sub arrays in a particular stack, right? Okay, totally fine. So now the next time when I will add our sub arrays in our stack, when there is no overlapping. So how we can check if there is no overlapping? Suppose I don't have this particular sub array, I am considering only these three sub arrays. Okay, so as you can see, there is no overlapping. Okay, so how we can check that? So sk.pick, so sk.pick, what it will give you? It will give you the last inserted one dimensional array. Okay, now I want to take our end index position. Okay, suppose sk.pick, what it will give you? sk.pick will give you pick, what it will give you? It will give you one dimensional array. Okay, so in this one dimensional array, in the 0th index position, or like first position, you will have your start. Okay, and in your second position, or like first index position, you will have your end. Okay, so I think it's clear, right? So what I will do now, so sk.pick, it will give you the one dimensional array. Okay, and then of 0, right? Okay, if I have stored this sub array, then this one will give you 2. Okay, this sk.pick of 0 will give you 2. Okay, I am just considering these three sub arrays. Okay, sk.pick of 0 will give you 2, and sk.pick of 1 will give you 6, right? I think this is also clear to you. You know how to access the arrays elements by the index positions only. Okay, I think it's also clear. So how we can check that particular two subarrays are not overlapping? For that, what we can do, we can just check that this particular sub, like I am considering only these three subarrays. Okay, I am telling this multiple times. Why so? Because I just don't want to confuse you. Okay, that's why I'm just saying the same thing again and again. So here I am just checking these three subarrays. Okay, just ignore this part for some time. Okay, I am taking these three subarrays. Then how we can check that this subarray and this subarray is not overlapping? So for that, what we can do, SK peak of 1, if we do, then it will give you 6, right now. So it should be less than intervals, okay, intervals of I of 0, right? I think this is clear. So means the starting should be greater than your last subarray ending, right? I think this is also clear, right? So if two subarrays is not overlapping, what does this mean? It means that your intervals of I of 0 means your starting index position of your particular subarray is greater than your last subarray ending, right? Also you can just push that particular element to your stack. Okay, I think it is also clear. So now last thing you have to only need to do, if they are having some overlapping, means taking these two subarrays, then you can see your second subarray starting is lies between your first subarray intervals, right? So that's why I can say, okay, it is overlapping. So I have covered all the scenarios when I need to push that particular element in our stack. So now there only one thing is remaining when they are having some overlapping. So if we having some overlappings, then what I will do sk dot peak, okay, of 0, sk peak of 0. Okay, so what I will store in these two values, I will take, and the minimum one I will store in our stack. Okay, you can see the same here. If I am considering these two subarrays, you can see between 1 and 2, here they are taking only the smallest one, because you have to check for the starting index position as lower value as possible, and for the ending value you have to check the as maximum value as you can take. Okay, so now at first I am checking for the starting one. So now you have to use math.min, okay, and you have to take the minimum starting as minimum as possible. Okay, so now sk the peak of 0, and the peak of 0, it will give you this 1. Okay, so here I am taking these 4 intervals itself, right? So for if this condition is satisfied for the first time, and we will simply insert our subarray 1, 3, right? So obviously sk peak of 0 will give you 1. Okay, and what next I need to do, position is representing the starting position only, and you have to find out the starting position as minimum as possible. Okay, and for the end index position, if okay, this is else but only execute when they are having some overlapping. Okay, so now sk dot peak of I, okay, and then math dot max. Why so? Because here I will check the as maximum as possible ending position or ending value. Okay, so sk dot peak of 1, okay. Why so? Because this interface of I of 1 will give you this 6 only, right? And this sk dot peak of 1 will give you 3. So if we have these two subarrays, then if they are having some overlapping, there as you can see it is true here that they are having some overlapping. In that case, I have to take the as minimum as possible starting and as maximum as possible endings. Okay, so as you can see, I am taking one stack of one dimensional array, right? So but you have to return it two dimensional array. So now only one thing is remaining. I have to convert this particular stack of integer array type, need to convert it into two dimensional array. Okay, so int of what will be the size. So our size will be sketch of size. Okay, and our row columns will be 2. I'm just printing this stack also. Okay, so now what I will do for, so now I will convert a particular stack into two dimensional array. Okay, this is our target now. Okay, so I am just traversing our stack. Okay, and here I am taking one integer type variable I, and this will be denote the index positions. Okay, what next I need to do, in the rest of I will store a and I will increment our I plus plus. Okay, and the end I'll just return our race. Okay, just run this once and let's see what happens. Okay, it is accepted. So like I was just printing our stack, that's why you got this kind of output. So I'm just doing it different way. Instead I am just adding this particular print statement in a particular for loop, and here I am done. Okay, so now if you just run it, and you can see in a particular stack also you will get the same output 1,6 and 8,10 15,18. This is the sub-arrays you have created in a particular stack. So this is the output that I wanted to show you. You can see in your particular stack you have the sub-arrays, and this sub-arrays is matching with our required sub-arrays, right? So this is what I just wanted to show you. Now you can just remove this line. There is no require of this line. So in this same sub-arrays we are storing in our two-dimensional array. Okay, two-dimensional array, you can see your row size is SKSO size, means your equal with your stack size, and your column size is 2. Why 2? Because in each sub-array you will have only 2 elements, right? So that's why your column size is 2 and your row size is equal with your stack size. So now means your stack size is 3, right? This is the first row, this is the second row, this is the third row. In this first column 1 8 50, and this is the second column 16 10 18. Okay, so I'm just converting the same in our two-dimensional array also. Okay, so that's the thing that I just wanted to show you. Okay, so now I'm just running it. So it is accepted, and now just submit this code once, then you will see some interesting thing. Okay, so now you got wrong answer. Why so? If you can see, at the first interval you have 1 to 4, and the second interval you have 0, 0. Okay, and it is your output 0, 4. Okay, but expected output is 0, 0 and 1, 4. Okay, so of this problem you can simply sort these sub-arrays. Okay, so this kind of problem didn't come to this first or like second example. Why so? Because as you can see, your sub-arrays are in sorting order, means they are in sequence, they are in ascending order, right? It's same goes for example 2 also, but in this example you can see they are not in sorting order, right? Because the first sub-array is starting from 1 to 4, but the second sub-array is starting from 0. So they are not sorting order. So what else we can do? We can just sort our two-dimensional intervals array. Okay, we can just do place of sort of intervals. Okay, you can think, okay, now it will be sorted and we will get our output, right? So now just run it. Okay, and let's see. So you can see it will give you runtime exception. So now what is the problem? Actually problem is array sort method is only applicable if you have one dimensional array, but you have two dimensional array. So that's why what else we can do? We can do customized sorting. So how we will do customized sorting, that I will explain now. So this is a two-dimensional array I have. Okay, so now what I'll do arrays ARR. So definitely it won't work. You can see the same here also. If you just run it, it will give you exception. Class cast exception. Same error was showing here also, class cast exception. So we cannot follow this. So we have to use customized sorting. So what I will do? This two-dimensional array I will sort based on the starting index positions. Okay. So it means that after sorting this particular array, what I will get 0, 0, and then next I will get 1, 4, because I will sort this particular two-dimensional subarray based on the starting index positions. Okay, so now if you see the other examples also, you can see these are in sorting order 1, 2, 8, 15, or like 1, 4. They are in sorting order. That's why I didn't get that problem that you got just now, right? Particular sorting technique, I will take each subarray, because each subarray is a one-dimensional array. In each subarray, I will take only the first element, because the first element is the starting position. Okay, so now if I just sort, okay, so first example it always in sorted order, that way I didn't get that issue. But when you got the interface in unsorted order, that case you got that problem, right? This problem you got now when your interface are not in sorting order. So you have to solve this kind of problem. So how we can sort these subarrays. Okay, so to sort these subarrays, what I will take, in each subarrays I will take the first element, means the starting element I will take, and I will sort each subarrays based on their starting positions. Okay, so now let's see how we can implement the same. So to do the customized sorting, we have to go with comparator. Okay, whenever you need to do any customized sorting, you have to use comparator. Okay, then comparator dot comparing you have. Okay, so basically comparing int you can use, or like comparing only you can use. Basically comparing int, it will return you the value in integer only, but you can go with comparing also. Okay, but in that case you have to specify your like input and output data type. Okay, so here I am using comparing, but again I am repeating the same. You can use the comparing int also. Why comparing int? Because if you don't know, I am just saying comparing int basically returns the integer type value. Okay, and this comparing, by comparing int, whatever you are working with, it is taking function. If you don't know what is function, I am just saying in brief, like if you know the functional interfaces, in functional interfaces you have 4 kind of functional interfaces, right? The predicate, consumer, function, supplier. These 4 functional interfaces you have. This comparing basically takes function as an argument. Okay, basically function takes an input and returns an output. Okay, so that input can be anything. Okay, so now I am just saying that input can be anything, right? So I am just taking subarrays. So subarray is a one-dimensional array. Okay, so each subarray, from each subarray, what it will return? It will return the first element, right? First element is 0th index position end, because to sort our interface array based on the subarrays starting positions. Okay, so I am just saying in brief. So basically it will give you what? It will give you like the first will give you 1, and the second it will give you 0, and array to sort, it will just sort this particular thing. Okay, 0 and 1. Okay, so it will just sort the arrays this way. So now if you just print it once, if you just run this one, then you can see it is in sorted order, and I have sorted these subarrays based on the starting index positions. Okay, so now also you can here use comparing int. Okay, so basically comparing int, it will make sure that you always returning only the integer values. Okay, so basically comparing int, it will take function as a argument, or you can implement the same here also. Like here I am checking what it will take. basically it will take two int function, right? So here I am for better explanation I'm just doing it, okay, and you can definitely ignore this part. Two int function, okay. So now here I will take one dimensional integer array I will take, and I'm just giving random names, okay, and then is then it will give you s of 0, okay. This is a function interface you have. Now you can just replace the same here also if you want to. You can just raise, you can use, right? So you can see it will work the same, right? So you have to know these kind of things. Like if you want to do customized sorting, then you have to go with comparator, then you have to comparing it, or even if you want you can use comparing or even comparing also, but in that case you have to use here comparing int, basically taking two int function, but only comparing it will take only function, okay. In that case you have to specify your like return value also. So here I'm specifying our return value is integer, right? So here I'm specifying the same here also, okay. If we just means the run test code, you can see the same, right? So basically you have to know this function very well. Basically when I was using two int, this two int function actually is saying to you that the whatever input you are giving, that is not a problem, but the output definitely be a integer only, okay. Array so sort method, what it will do, like if you have some, so array so sort method how it will work, like if you have random values you have, okay. So suppose I am taking integer type array, so this array so sort method just what it will do, it will just sort this particular array, right? Like first it will be 1, then 3 and 23, right? So it will just sort our particular array. So same phrase, so basically this phrase is giving you the, like suppose you have s is kind of like, suppose suppose this is the s, okay. I'm just taking random things, okay. So 9 comma 12 you have the s you have, okay. So now this function will give you 9 only. Why so? Because this race will give you 9 only, okay. Because this is the how this function is working. Like suppose if you are giving any one dimensional array, then it will provide you the 0th index position element. That's why this race equals to 9. So now when you are doing array so sort method, now it is just sorting you that particular starting index positions only. Suppose if you have this two dimensional array, then this comparing int of race will give you like the starting index position, like first starting index position is 1 and second subarray starting index position is 0, okay. And this sort method will apply on this only, and now it will sort to 0 comma 1, okay. Now I will write down the same in our code also, okay. So now let's see the description and let's go to our code, okay. So this is not we cannot do. So now instead of ARR I will use intervals, okay. So now run it, okay. Now it is accepted. Now just submit this code once, okay. So this one you can just do the logic part here, even in here also, okay. Now just run this code and it will definitely work, okay. So I'm just reducing the number of the lines of your code, okay. So now let's see the code again, just giving a quick overview. So first I am taking one stack and the data type of the stack is array of integer type, okay. So now here I am just sorting our subarrays. So in the first or the second example already our interface in the sorting order, that's why we didn't think about it that it may possible the subarrays can be in different orders. So because of that may possible subarrays can be in different orders also. So that's why what I will do, I will just sort our subarrays, okay, based on their starting index positions, because these arrays are in sorting order based on the starting index positions. If you can see, like first you have 1, then 2, then 8, then 15, or like here also 1, then 4. They are all in sorting order based on their starting position. So that's why you didn't face any problem in your normal test case. But for the hidden test cases, they have mentioned the summary in the random order. So that's why you face that issue, that way you have to sort the surveys first. Okay, so I have sort the surveys. Okay, so now I am just traversing our interface arrays. Okay, so now if our stack size is totally 0, there's no need to think about it. We'll just push whatever value we have in our survey. Okay, so else part, if there is no overlapping, so this if condition is about if there is no overlapping, then also we'll just add our particular intervals in our particular stack. Okay, in the else part, this is the else part when there is a overlapping. If there is a overlapping, suppose two averages you have and there's two averages they are overlapping, so in that case for the starting position I will take as minimum number is possible, and for the ending position I will take as maximum number is possible. Okay, this is the one thing, and this is the simplest thing. Here I have just converted our stack into the two-dimensional array, because we have to return two-dimensional array only. That's why here I have just do the conversion. Okay, this solution and this question both are clear to you, but still if you have any doubts, any concerns, please let me know in the comment section. And if you like my videos, don't forget to subscribe to my channel and like this video. So thanks for watching. See you in the next video. Bye bye.